In example 2, we also want to use the elimination method. First of all, if we take a look, we have our x and then our y and then our constant, but in the bottom one we have our y and then our x. It makes it a lot easier to solve using the elimination method when our x's and our y's are lined up. So let's start by rewriting the function, or the system. So I'm going to leave the top equation alone, leaving the x first, 2x minus 4y equal to 8. And then I'm just going to rearrange the bottom on the left-hand side. Remember, if you rearrange on the same side, the signs don't change, you're just moving spots. So I'm going to put the positive 3x first, and I'm going to put the minus 5y second, equal to negative 13. So now I've lined up my x's and I've lined up my y's, looking to see if I can eliminate either one of them. Well, the coefficients in front of the x's are not the same number or opposites. Same thing with the y's. They are not opposites either. So then I need to look and see, can I multiply one equation by a certain number to get my opposite coefficients? If I look at my x's, I always want to look at the smaller coefficient to see if I can multiply it by something to get the bigger coefficient. There's no nice whole number to multiply 2 by in order to get 3. Same thing goes for my y's. There's no nice number to multiply 4 by in order to get 5. So what happens is you might have to multiply both equations. So what I'm going to do is I'm going to multiply the top and the bottom equations. And one thing to do is you want to get opposite coefficients. So you can take the coefficient, if I'm going to eliminate my x's, I can take the coefficient from the bottom, that 3, and multiply it to the top. And I can take my coefficient from the top, that 2, and multiply it to the bottom equation. 3 times 2 is 6, and 2 times 3 is 6. So by using these coefficients as the multipliers, we will always get the same number. Now what you have to be careful about is the signs. We want one of these to be negative. So if we look at what we have to begin with, both of these are positive. Since both of these are positive, we need one of these numbers we multiply through by to be negative. And it really doesn't matter which one. It's totally your choice. I'm just going to go with the bottom one and make that a negative 2. So now when I multiply, I will be able to get opposites. So if I take the 3 on the top and multiply it through, I get 3 times 2x, which is 6x. And then I have 3 times negative 4y, which is negative 12y. And then I have 3 times 8, which will give me 24. And then if I multiply through on the bottom, negative 2 times 3x is negative 6x. Negative 2 times negative 5 is a positive 10y. And negative 2 times negative 13 will give me a positive 26. Then I double check, since I'm looking to eliminate my x's this time, I need to check that what I multiplied through by gave me opposites. So I have a positive 6 coefficient on the top and a negative 6 coefficient on the bottom, which are opposites, which means I can go ahead now and add these together. If I add 6x and negative 6x, I get 0, so those cancel out. Then I have negative 12y plus 10y, which is negative 2y. And then I have 24 plus 26, which is 50. Then to solve for y, all I have to do is get rid of the negative 2, and since it's being multiplied, I can divide to get rid of it. And I get y is equal to negative 25. And now what I need to do is I need to get my x value. So I'm going to take my y value of negative 25, and I'm going to plug it back in to one of my original equations. So coming back, I can either do the top one or I can do the bottom one. I'm just going to do the top one. And I have 2 times x minus 4. And since I know what y is now, I'm going to plug the negative 25 in for the y right there. So times negative 25 equals 8. And then solving for x, I can multiply negative 4 times negative 25 is positive 100. So I have 2x plus 100 equal to 8. Solving for x, then I would have to subtract the 100 from both sides. And I get 2x equal to negative 92. And then lastly, I would have to divide both sides by 2, giving me x equal to negative 46. Then from here, what I want to do is I want to check my answers. So I'm going to do my check step to make sure my answers are correct. Starting with the top equation, I have 2 times the x value, which is negative 46, minus 4 times my y value, which is negative 25. And I want to make sure that that's equal to 8. Now, 46 and 25 for some of you might be a little hard to do in your head. So at this point, I would just take my calculator out and plug this all in at one time. 2 times negative 46 minus 4 times negative 25. And when you hit enter, you should see that you get 8. So we know that 8 is equal to 8, and it works for the first equation. Remember, we cannot tell by just the first equation. We also have to plug it into the second equation to make sure that this works. So now I'm going to go to my bottom equation, negative 5y, and instead of the y, I'm going to plug in the negative 25, plus 3x, and instead of x, I'm replacing it with negative 46, equal to negative 13. Again, my numbers are kind of large, so feel free to use that calculator. Negative 5 times negative 125, plus 3 times negative 46. Plug that in your calculator all at once. After you hit enter, you should see that you get negative 13 is equal to negative 13, which tells us that the second equation works as well, meaning that our answer is x is equal to negative 46 and y is equal to negative 25. You could also write it as an ordered pair as negative 46 comma negative 25. Next, I would like you to pause it and do the try this. Unpause it when you're ready to check your answers. If you did the try this correctly, you should get the ordered pair of 3 comma 2, or x is equal to 3 and y is equal to 2. Please let me know if you need any help.